The objective is to recognize an unreliable airspeed condition and take the appropriate action. Some of the possible causes are as follows: blocking or freezing of the pitot system, a severely damaged radome, a missing radome, air data computer malfunctions or failures, pitot probe covers not removed during the walk-around, or volcanic ash. These are just some of the possibilities. Taking off is one of the most important parts of our flight because of what happens as we accelerate, ensuring that all engines are operating properly and flight instruments are properly indicating. So the 80 knot call is most important, and it is made by the pilot monitoring. And we have a slide here that indicates a difference in the captain's indicated airspeed and the first officer's indicated airspeed. At 80 knots, the first officer would call 80 knots. The captain would check his or her airspeed and ensure that it is the same and respond, check. This is important for a couple of reasons. One, that both pilots are really capacitated and not incapacitated. And the other is a perfect time to check the airspeed indicators. So if the situation arose that we see on screen, the captain would call reject. So recognizing the problem early in the flight cannot be overemphasized. Very important. Let's have a look at the condition of plugged pitot tubes. During the takeoff roll, airspeed remains pegged at the lower stop. It's not going to move. Regardless of actual aircraft climb speed, the faulty airspeed indication continues to increase as altitude increases until the airspeed catches the correct value. However, continues to increase through the correct value as the aircraft climbs. Now these things would trigger one of the pilots or both pilots to say, hey, there's something wrong here. On the other hand, plugged static ports during the takeoff roll, both the altimeter and airspeed indications work normally. After liftoff, the aircraft actually climbs at a constant speed. The airspeed indication decays and reaches the lower end indication. If the airspeed indication is relied upon, the typical response will be to reduce the pitch attitude to maintain the erroneous speed indication, possibly causing the airplane to exceed its airspeed limitations. Complicating the situation is the fact that the overspeed warning does not operate if connected to the erroneous airspeed source. Early recognition is important. Let's go to the FCTM before we get into a few of the other items that you see here. So looking at the FCTM, we'll just slide it over here so that we can look at it together. Some of the highlights, there's a lot of very good information in the FCTM, and that's a pilot's Bible, of course. So I've highlighted some of the key points. Increased reliance on automation has de-emphasized the practice of setting known pitch, attitudes, and thrust settings. We've been too complacent with respect to the basic flying skills. And really on initial type rating course, the day one should really be dedicated to flying the aircraft without the new technology. That is raw data, your ADI and your pitch reference and manual thrust without auto thrust and no AFDS systems, no computers assisted information is very important. And I realized that when I first went on the 767 in 1985, I found it difficult initially to realize that really all of the automation is probably correct. And I say probably is our job and our task as pilots today is to ensure that it's correct by using raw data. Raw data is so important. And really, I think of raw data as the cake. If we look at a cake, so just take the cake itself and call that the raw data. Now you're going to put icing on the cake. Let's use magenta color for the icing. Well, that is your computed information. That's extra. And if you really think of the command bars and all the information you're getting from the FCCs as really extra information, you'll have no problem flying new technology aircraft.